One more example of graphing a logarithm and transformations of it. Example 5b, we are graphing y equals 2 times the log base 3 of x plus 3 minus 1, and then comparing to our parent function. Okay. We start off thinking about what on earth our parent function actually is. So our parent function at its core is the log base 3 of x. Okay? So from here, let's think about, well, what does this mean? The log base 3 of x. Well, it means 3 to the y power equals x. Just like before, let's make our table of values where we choose our y's to be -2, -1, 0, 1, and 2. After we get our table, then we'll do all of these other transformations that happen. So 3 to the -2nd power is 1 over 3 squared, so 1/9. 3 to the -1st power is 1/3. 3 to the 0, 3 to the 1st, and 3 to the 2nd. So from here, what transformations do we have? Well, this plus 3 inside is going to move our graph left 3. The 2 in front is a vertical stretch. By 2. And then the -1 at the end is translated down 1. So we have to change our values in our table accordingly. If we're going left 3, our x values change. We have to subtract 3 from each one. So a 9th minus 3 would be -2 and 8/9. A 1/3 minus 3 would be -2 and 2/3. 1 minus 3 is -2. Minus 3 is 0. Minus 3 is 6. A vertical stretch means we have to multiply all of our y values by 2. So this is -4, -2, 0, 2, and 4. And then translate down 1. We subtract 1 from each y value. So -5, -3, -1, 1, and 3. Now these are the points that we're going to plot. -2 and 8/9 is not quite -3. And then down 5. The -2 and 2/3, -3. -2, -1. Then we have 0, 1. And then 6, 3. Okay. So this graph, we see a pretty exaggerated curve here because we have that vertical stretch in here as well. And again, our asymptote has now been translated because we have the translation left 3. So the asymptote now in this problem is that x equals -3.